On November 17th, a moment that initially seemed routine within the astronomical community rapidly transformed into the starting point of an unprecedented scientific upheaval as the interstellar object designated 3IATLAS revealed characteristics that defied every established model of cometary behavior. Data streamed in from the James Webb Space Telescope, whose near-infrared and mid-infrared instruments recorded reflections and geometric surface patterns utterly inconsistent with dusty, diffuse comet structures and instead indicative of something possessing ordered architecture. Physicist Michio Kaku added to the escalating tension by publicly stating that Atlas appeared to contain signs of life, or at least processes resembling life, a statement grounded not in speculation, but in the accumulation of anomalies impossible to dismiss. Unlike the outgassing plumes and chaotic coma dispersal expected from long-period comets approaching solar warmth, Atlas presented a sharply defined silhouette, with hexagonal surface motifs shimmering in ultraviolet scatter, patterns that maintained alignment independent of changing solar angles. Such symmetry could not be attributed to natural crystalline arrangements, especially given their persistence through several observation windows. As global observatories, including Subaru in Hawaii and ESA's Gaia platform, synchronized their measurements, they noted fluctuations in Atlas's reflectivity that aligned with solar angle shifts, as if the object were actively modulating its optical output. Light curve variations that should have corresponded to solar wind turbulence instead mapped to predictable orbital geometry, suggesting response rather than reaction. The Planetary Defense Coordination Office initiated an emergency internal review, triggering real-time data sharing across agencies typically slow to cooperate. Analysts at the Max Planck Institute identified reflectivity adjustments, occurring fractions of a second before solar angle changes were measurable from Earth, a phenomenon that implied anticipatory behavior. Meanwhile, spectral lines recorded from the object formed narrow coherent signatures rather than the diffuse scatter expected from organic dust or sublimated ice. These emissions indicated a highly ordered surface composition incompatible with random cosmic formation. The more datasets accumulated, the more Atlas resisted categorization. Its rotational behavior lacked the wobble typical of binary fragmentation or uneven mass distribution. The orientation held with uncanny stability, shifting only through subtle, controlled adjustments that suggested torque management rather than chaotic tumbling. Each new observation deepened the challenge. Instead of acting as an inert interstellar fragment, Atlas behaved as though guided by internal rules, preserving structural coherence under conditions that should have induced thermal fractures or volatile eruptions. Scientists found themselves forced to confront possibilities outside conventional astrophysics. Was Atlas merely unusual, or did it represent a structured system whose reactions followed a logic beyond geology? Environmental interactions, spectral anomalies, and geometric consistency all pointed in the same direction. The object was not just arriving, it was arriving with behavior, with patterns, with unmistakable signs of underlying organization. By the end of that first day, the astronomical community understood that 3IATLAS would not be studied as a comet or asteroid. It had become something else entirely, a riddle moving through the solar system with the poise of an engineered or at least self-regulating entity, and November the 17th marked the moment when the mystery truly began. The coordinated international observation campaign that unfolded after Atlas's initial detection rapidly transformed from a routine data-gathering effort into a crisis-level scientific undertaking, as the object's behavior deviated further from every known natural model. Over the next 11 days, telescopes across the globe space-based and ground-based alike locked onto Atlas with unprecedented synchronization. The James Webb Space Telescope maintained continuous spectroscopic surveillance, while instruments at Subaru, Gaia, LaCie, and additional auxiliary arrays mirrored its tracking intervals to ensure that no gap appeared in the monitoring timeline. What emerged from this multi-layered dataset was a profile of an object that behaved less like a drifting fragment of interstellar debris and more like something adjusting itself in real time to its environment. Instead of the chaotic fluctuations typically seen in comets responding to uneven heating, Atlas modulated its reflectivity with clockwork precision in correlation with solar angle changes. The modulation did not merely occur after the shift in illumination. In many cases, it appeared to precede it by fractions of a second, as though the object predicted how incoming sunlight was about to strike its surface. Light curve analysts confirmed that these reflectivity transitions could not be attributed to sensor noise or calibration drift. They repeated across independent platforms, forming a consistent pattern of anticipatory response. The behavior became especially alarming when orientation data revealed that Atlas was not tumbling chaotically. Natural bodies with irregular geometry inevitably develop torque imbalances, causing unpredictable rotation. Atlas, however, executed minute orientation shifts that stabilized its trajectory rather than destabilizing it. These adjustments resembled controlled micromaneuvers, almost like vector corrections, despite the complete absence of observable propulsion mechanisms. This discovery prompted the Planetary Defense Coordination Office to initiate a rare cross-agency review, leading to instantaneous data sharing between NASA, ESA, and several national observatories that usually collaborated far more slowly. The internal consensus, though never publicly acknowledged, was that Atlas was demonstrating non-passive behavior. As additional spectral readings arrived, they reinforced this interpretation. Instead of the broad, messy spectral signatures produced by dust plumes, Atlas generated narrow, columnated spectral lines that suggested an orderly surface composition, something structured, consistent, and potentially engineered. Analysts struggled to reconcile these findings with natural astrophysics. Even exotic comet models involving hypervolatile compounds failed to account for such coherence. Complicating matters further, reflectivity shifts occurred not only in response to solar geometry, but also during shadowed intervals, where no direct illumination changes were present, implying that the object was tracking some internal or external reference beyond simple light exposure. As the synchronized observation campaign reached its midpoint, scientists watching the data feeds realized they were not merely observing an interstellar curiosity. They were witnessing a phenomenon that operated outside every established category of celestial objects. Atlas interacted with its environment in ways that suggested situational awareness subtle, perhaps mechanistic, but unmistakably rule-driven. The deeper the monitoring networks probed, the more apparent it became that this was not a body drifting through the solar system by chance. It was behaving as though it had preferences, thresholds, and internal mechanisms that guided its responses. What began as coordinated observation had evolved into coordinated concern, as Atlas continued to exhibit an eerie, systematic precision that science had no language for yet. When Atlas re-emerged from its 73-hour disappearance behind the solar curtain, researchers expected minor variations in its surface condition due to intense heating. Yet what greeted them instead was a thermal landscape, so structured and coordinated that it forced an immediate re-evaluation of every natural model previously applied to the object. High-resolution infrared imaging from JWST, combined with thermal maps from Earth-based observatories, revealed an organized lattice of hotspots, arranged with geometric precision across Atlas's surface. These hotspots did not scatter or drift as an ordinary comet's thermal gradients would. Instead, they maintained consistent spacing relative to the Sun, adjusting their intensity in a rhythmic sequence that looked less like passive heating and more like regulated energy distribution. The pattern pulsed, rising, dispersing, then resetting on intervals too stable to be dismissed as turbulence or sublimation delay. As analysts stitched together time-lapse thermal overlays, they found the hotspots were connected by elongated corridors of elevated temperature that branched across the surface in intersecting pathways reminiscent of vascular or neural networks. These corridors reacted dynamically to changes in illumination, rerouting heat toward or away from specific nodes in a manner that implied some internal feedback system. Natural cometary crusts do not reconfigure their heat flow with such precision. They fracture, they shed mass, they scatter energy in chaotic gradients. Atlas, by contrast, behaved like something maintaining internal equilibrium through deliberate redistribution. Further compounding the mystery, JWST's long-duration scans detected cyclical thermal pulses recurring every 243 to 248 seconds, a range so narrow and so consistent that random geological or chemical explanations became statistically implausible. Independent verification from multiple platforms confirmed the pulses originated from beneath the surface, rather than from sublimation jets or surface flares. The pulses were not artifacts, they were signals of an organized internal process. Alongside these thermal revelations, spectroscopy mapped clusters of asymmetric carbon chains across Atlas's reflective surface. These molecular structures exhibited biased chirality, far exceeding what abiotic chemistry typically produces. More intriguingly, the regions of chirality bias aligned with certain thermal nodes, creating zones where heat and molecular organization appeared interlinked. This correlation challenged the notion that Atlas's chemistry was incidental. Instead, the molecular environments looked regulated, as if specific compounds were synthesized or stabilized in tandem with thermal cycles. Analysts attempting to classify the combined data found themselves unable to keep the biological and non-biological interpretations separate. The thermal pathways resembled circulation. The rhythmic pulses resembled metabolic pacing or system diagnostics. The molecular consistency suggested selective synthesis. Even the stability of Atlas's surface geometry under fluctuating solar conditions appeared coordinated. Every new measurement deepened the same conclusion. Atlas exhibited complex organization rather than chaotic byproduct. By the end of the post-perihelion analysis window, a quiet consensus emerged across several research teams, though no one dared say it publicly. What they were observing did not behave like rock, nor like ice, nor like any inert mass drifting through interstellar space. It behaved like a system. Adaptive, structured, regulating itself with purpose. The boundary between geology and biology had blurred, and Atlas was forcing the scientific community to confront the possibility that the object wasn't simply enduring its solar encounter, it was responding to it. The deeper Atlas travelled into the inner solar system, the more its behaviour began to resemble deliberate environmental management rather than passive physical response. And nowhere was this more evident than in its astonishing ability to anticipate solar conditions before they occurred. Instruments across multiple observatories recorded changes in Atlas's thermal profile that preceded fluctuations in solar flux by measurable intervals, an ability no natural body possesses. Instead of gradually warming in response to incoming radiation, Atlas shifted its surface temperature distribution in advance, cooling some regions while insulating others, as though running predictive calculations on the surrounding space weather environment. This phenomenon became even more dramatic during a sudden surge of solar wind near its post-perihelion arc. As other celestial bodies would destabilize or fragment under such stress, Atlas released a plume of hydrogen and carbon radicals exclusively from its shaded hemisphere. This plume curved in a tight, coherent arc, behaving nothing like a normal jet of sublimated material. It maintained formation across several kilometers, mirroring the object's motion and counteracting torque that should have spun Atlas into chaos. The maneuver resembled controlled venting, a directional response precisely aligned to preserve stability. When observational teams attempted to replicate the plume trajectory using models of chemical ejection, no simulation came close to reproducing the pattern. Natural outgassing could not form a consistent arc. Natural jets could not maintain structural coherence. The plume's behaviour suggested not only active control but also strategic deployment. Reflectivity data added yet another layer of strangeness. During periods of increased photonic pressure, Atlas's surface uniformly darkened by nearly 18%, an abrupt optical shift far too coordinated to result from dust redistribution or rotation. Then, when the pressure diminished, the surface brightened again, returning to its previous albedo signature. The transition resembled an adaptive camouflage response, not for concealment, but for environmental resilience, as if Atlas were modulating its surface to regulate energy intake. Biologists on the interdisciplinary review panels compared the effect to biological photoprotection or variable pigment expression, but the process unfolded with a mechanical precision that suggested a hybrid of signaling, shielding, and self-preservation. The mystery deepened further when rotational analysis revealed that Atlas's axis was slowly aligning with its direction of travel. Rather than tumbling from uneven venting or gravitational interactions, the object executed micro-adjustments that collectively formed a smooth, purposeful reorientation. Backtrace simulations showed that this alignment began hours before the solar event that should have triggered instability, indicating once again that Atlas was acting on foresight rather than reaction. This forced analysts to adopt hypotheses they had previously rejected outright. Perhaps Atlas possessed internal systems capable of environmental sensing, predictive mapping, or even data processing. Theories ranged from smart material exoshells to self-regulating thermodynamic cores, and though none could be verified, all shared a common premise. Atlas was functioning according to principles of adaptation rather than chance. By the end of this observation phase, the object no longer fit anywhere within the taxonomy of comets, asteroids, or interstellar debris. Atlas behaved like an entity executing operational protocols, protecting its structural integrity and managing external variables through calculated adjustments. It was no longer possible to describe its motion as drift. Atlas appeared to be operating. Spectroscopic instruments trained on Atlas during its next observation window revealed chemical behaviors so intricate and patterned that the object's already mysterious nature took on an even more bewildering dimension, for its molecular emissions did not resemble chaotic cometary outgassing, but instead unfolded like coordinated system-level processes. High-resolution data from JWST, ALMA, and the Vera Rubin Observatory showed that Atlas released long-chain hydrocarbons and amino-bearing molecules in pulses synchronized with its rotational period. These emissions emerge from discrete fixed points on its surface rather than from fractures or volatile-rich fissures, and each point activated in sequence, forming a chemical rhythm that repeated with astonishing stability. The compounds included glycolaldehyde, alkene series, amine precursors, and carbon clusters commonly associated with prebiotic environments, yet their distribution defied natural randomness. Instead of drifting outward as diffuse clouds, they formed concentrated plumes that maintained structural coherence for several seconds before dispersing, as though the emissions were being regulated rather than explosively vented. The spectral profiles displayed a layered architecture, broad organic signatures accompanied by narrow, sharply defined peaks, indicating selective chemical pathways. This selectivity suggested that the molecules were not merely present, but were being produced or released through a controlled mechanism. Most perplexing was the detection of phosphorus-rich microbursts, arranged in repeating hexagonal patterns across Atlas's high reflectivity regions, mirroring the geometric surface motifs noted during earlier observations. Phosphorus in such patterned concentrations is extraordinarily rare in non-biological contexts, yet here it appeared in a lattice-like network that synchronized with both thermal pulses and chemical releases. The coordination was too precise to attribute to natural crystallization or outgassing. Further confounding analysts was the bilateral symmetry observed during a methane-nitrogen emission event, captured by ESO's extremely large telescope. Instead of expanding in an uneven bloom as cometary jets typically do, the material split into two mirrored lobes that maintained equal energy distribution and matched dispersal velocities. The emission looked engineered balanced, responsive, and regulated by an internal constraint that forced symmetry. Chemical modelers attempting to reverse engineer the event found no plausible abiotic mechanisms that could produce bilateral jet partitioning under such conditions. The rotational spectral data heightened the mystery. Every 247 seconds, Atlas produced a narrowband pulse of complex organic signatures accompanied by slight phase shifts in its thermal readings, suggesting that chemical activity and heat regulation were linked. These pulses did not vary with temperature, solar wind conditions, or illumination angle. They behaved as if driven by a timing system. The convergence of rhythmic chemical cycles, structured molecular clusters, and symmetric emissions began forcing researchers to confront hypotheses they had previously avoided. Some teams proposed that Atlas might contain microenvironments functioning like biochemical reactors. Others suggested the emissions resembled diagnostic or maintenance cycles of an engineered system. A more radical minority speculated the object could be a hybrid part mineral, part molecular construct, a system capable of organizing chemistry into repeatable, regulated patterns. Regardless of interpretation, one fact became inescapable. Atlas was not simply carrying complex molecules, it was orchestrating them, producing emissions with timing, geometry, and selective composition that indicated underlying processes far beyond anything seen in natural celestial bodies. The deeper researchers probed into Atlas's molecular composition, the more they realized that ordinary spectroscopy could not fully explain the object's behavior, because beneath the chemical anomalies lay an even more unsettling discovery. Atlas consistently produced optically active molecules with a pronounced chiral bias, a hallmark of selective synthesis rather than random interstellar chemistry. Chirality. The property of molecules existing in left-handed or right-handed forms is crucial in biological systems, where life overwhelmingly favours one orientation. In Atlas's case, repeated measurements revealed a persistent dominance of L-chirality, matching the orientation found in terrestrial amino acids. This was not a minor skew, but a strong, statistically impossible preference for a random extraterrestrial object. Scientists attempted to attribute the bias to polarized stellar radiation, magnetic field alignment, or asymmetric sublimation. Yet none of these mechanisms could produce such consistency across varying solar angles and observation periods. Even more bizarre was the way these chiral molecules appeared on Atlas's surface. Instead of forming in dispersed patches, they organized into crescent-shaped bands that migrated gradually across the object's hexagonal reflective structures, creating moving ribbons of chiral enrichment that seemed to flow along predetermined paths. Time-resolved imaging showed that these crescents brightened and dimmed in coordination with Atlas's thermal pulses, as if molecular orientation and heat cycles were interconnected in a programmed sequence. The crests of these ribbons aligned with earlier identified thermal nodes, suggesting that chirality production was not evenly distributed, but channeled through specific surface regions. This behavior implied a selective process, either a biochemical preference or a system designed to favor certain molecular configurations. As additional observatories analyzed polarization data from the emitted molecules, they detected optical rotation signatures that varied predictably with Atlas's rotational phase. Natural sources of optically active molecules do not exhibit synchronized optical rotation tied to a body's spin. The correlation suggested that Atlas was not merely producing chiral molecules, but cycling them, organizing them, perhaps even utilizing them. This led to a cascade of internal debates across research institutions. Biologists argued that the chiral patterns resembled primitive biosynthesis or metabolic structuring, while materials scientists proposed that Atlas's surface might contain smart material lattices capable of selectively sorting molecules by orientation. Astrobiologists pointed out that even the simplest asymmetrical distributions of chirality in natural environments are noisy and irregular, whereas Atlas's patterns were smooth, periodic, and mathematically constrained, more like the output of a controlled system than the byproduct of chance. The chiral crescents also displayed a curious interaction with the sun's ultraviolet radiation. When subjected to heightened UV intensity, the bands expanded and intensified, only to contract back to their original size once the radiation subsided. This reversible behavior indicated that the molecules were not simply deposited, but were actively maintained and reconfigured, responding to environmental feedback in a way akin to photoreactive biological systems on Earth. Chemical modelling struggled to keep pace with the data. Every attempt to simulate random abiotic formation failed to replicate the observed symmetry or periodicity. The only models that approached the real behavior required assumptions about selective molecular processing, something akin to enzymatic sorting or catalytic patterning. Such concepts, when applied to a multi-kilometre interstellar object, strained credulity. Yet every new measurement reinforced the same realization. Atlas was not a passive storehouse of organic molecules. It appeared to be engaging in molecular organization, producing and modulating chirality with precision, rhythm, and spatial patterning that no known natural object could generate. The thermal behavior of Atlas, already anomalous in earlier observations, escalated into something even more elaborate as researchers focused on the object's deeper, structural responses to solar energy, revealing a network of heat pathways and phase-shifting materials that appeared to operate together like components of a unified system. High-resolution thermal mosaics from JWST showed that Atlas's hotspot lattice, previously assumed to be static, continuously reconfigured itself, with nodal points fading, brightening, and migrating across the object's surface in coordinated sequences. These migrations did not follow the chaotic patterns expected from differential heating. Instead, they traced precise geometric routes, as though Atlas possessed an internal grid capable of redistributing thermal load with strategic intent. The corridors of heat observed earlier now behaved like flexible conduits, rather than fixed structures. They rerouted thermal energy in response to solar flux variations, forming temporary junctions that connected or disconnected nodes depending on illumination, solar wind density, and the object's rotational angle. This adaptability suggested that the network was composed of materials with dynamic thermal conductivity substances capable of switching between insulating and conductive states. Laboratory simulations attempting to replicate this behavior using known phase change compounds failed to reproduce the speed and precision of the transitions. Phase-shifting materials on Earth can be coaxed into altering conductivity under controlled temperature thresholds, but they cannot do so in orchestrated patterns involving dozens of nodes across a rotating multi-kilometre body. ATLAS, however, performed such transitions with near-synchronous timing, as if guided by an internal logic that prioritized stability and energy optimization. Spectroscopic scans identified unusual mineral composites forming the backbone of the thermal grid. Some compounds showed signatures consistent with silicate matrices, while others displayed infrared behavior characteristic of engineered metamaterial structures that altered their refractive and conductive properties under variable radiation. The coexistence of these disparate materials in patterned arrangements defied any natural formation mechanism. Even more surprising were the phase shift zones, regions where the spectral properties of the surface abruptly transformed from crystalline reflectivity to a darker, more amorphous state. These shifts occurred during spikes in thermal load, creating patches that absorbed incoming radiation rather than reflecting it. When the load decreased, the zones reverted to their prior structure, regaining reflectivity with almost no degradation. This reversible transition looked eerily similar to active heat buffering, a process reminiscent of biological thermoregulation, but executed on a geologic scale. Observatories also detected moments when entire sections of the thermal grid synchronized, initiating a ripple of heat pulses that traveled across Atlas's surface like a wave. These ripples timed themselves with the object's internal pulse interval, suggesting that Atlas used thermal propagation as part of a broader orchestrated system, potentially a signaling mechanism, a stability adjustment cycle, or a method of distributing absorbed solar energy evenly across its shell. Analysts compared the phenomenon to primitive neural conduction, or to the coordinated behavior of programmable materials, but no analogy was fully adequate. The reality was that Atlas's thermal networks demonstrated integration, responsiveness, and coherence far beyond any known natural process. By this point, even the most conservative researchers had begun to concede that Atlas's thermal behavior represented a form of active temperature management, something akin to a large-scale organism distributing metabolic heat or a technological construct maintaining operational thresholds. In either case, the object acted with purpose. It did not endure the solar environment, it adapted to it, reshaping its own surface properties and internal heat flow with an elegance suggesting structure, system, and underlying design. The chemical and isotopic analysis of ATLAS entered a new phase once researchers began isolating its elemental signatures, and what they discovered overturned one of the most fundamental assumptions in planetary science. The object did not match the chemical isotopic profile of anything formed within the solar system, nor did it resemble any known class of interstellar comets. Instead, ATLAS displayed isotope ratios that pointed toward an origin in ancient prebiotic regions of the galaxy zones that existed billions of years before the formation of the Sun. Carbon isotopes, typically reliable indicators of formation conditions, showed an enrichment pattern, characteristic of cold molecular clouds that predated the solar nebula by immense spans of time. The carbon-12 to carbon-13 ratio was skewed in a way never observed in comets from the Oort cloud or from interstellar visitors like 2I Borisov. Nitrogen isotopes told an even stranger story. Atlas's nitrogen-15 abundance was so anomalously high that the only known environments capable of producing such ratios were regions subjected to prolonged cosmic ray exposure during epochs of early galactic evolution. These readings suggested that Atlas had been exposed to processes that had not shaped any object in our local system, hinting at a chemical lineage older than the majority of nearby stars. Oxygen isotopes further compounded the mystery. Natural bodies tend to display variations that correlate with their stellar nursery, yet Atlas's oxygen-17 and oxygen-18 abundance fell outside every established category, aligning instead with theoretical predictions for objects formed in highly specific and extremely ancient interstellar nurseries, places where heavy elements were still distributing unevenly after supernova enrichment. The implication was staggering. Atlas was not simply foreign, it was primordial. Age estimates derived from isotope decay pathways suggested that the object might have existed for billions of years. Yet the paradox was impossible to ignore. How could a structure as complex, adaptive, and coherent as Atlas have persisted across such an immense span of time without degrading into inert rubble? This enigma deepened when researchers mapped isotope concentrations across its surface and found clear patterns that suggested selective preservation or even controlled processing. Isotopically enriched zones clustered around the thermal nodes identified earlier, while depleted zones aligned with the phase shift corridors of Atlas's conductive grid. These distributions were too precise to attribute to random cosmic erosion or uneven exposure. Instead, they resembled zones of resource allocation, as if Atlas organized its isotopic materials according to functional needs. Some geochemists proposed that Atlas might be an ancient molecular archive, a remnant vessel, preserving chemistry from epochs of early star formation. Others argued that the isotope patterns resembled sustained chemical evolution, suggesting that Atlas's internal systems actively maintained certain ratios to support ongoing processes. A more radical hypothesis emerged as researchers compared the isotope maps with the structured chemical emissions documented days earlier. The isotopic gradients mirrored the pathways along which complex molecules were emitted, hinting that Atlas might be using isotopes in the same way biological systems use cofactors or catalytic environments. This raised a question almost too bold for publication. Had Atlas undergone some form of directed evolution? If the object was indeed billions of years old, its chemical systems might have adapted over time, refining its internal organization across unimaginable spans of interstellar drift. Whatever the mechanism, one conclusion became unavoidable. Atlas was not simply a relic of ancient cosmic chemistry. It was a participant in it, an enduring structure that had preserved, organized, and perhaps even evolved its isotopic and molecular composition across galactic epochs. The next revelation about Atlas emerged not from its heat signatures or chemical composition, but from its luminous behavior, an unexpected display of bioluminescent-like emissions that suggested the object interacted with light in ways no comet or asteroid ever had. As Atlas rotated through regions of reduced solar illumination, instruments began detecting faint glows emanating from its shadowed hemispheres, a phenomenon utterly incompatible with reflected sunlight. These emissions were cold-region photoluminescent pulses that brightened and dimmed in synchronized intervals, following a stable rhythm that matched the internal thermal cycle documented earlier. Instead of scattering randomly across the surface, the light emerged from specific bands that traced Atlas's hexagonal structures, illuminating them in arcs that resembled the flicker of a heartbeat or the pulse of a signaling system. The glow was not constant, but responded sharply to thresholds in solar radiation. Each time sunlight dipped below a certain intensity, the photonic output increased in strength, as though Atlas compensated for the lack of illumination by producing its own. Conversely, when solar exposure peaked, the internal glow subsided but never disappeared completely, maintaining a faint baseline that persisted even during maximum glare. This persistence was unlike anything seen in photoluminescent minerals, which typically require sustained excitation and cannot produce rhythmic autonomous light emissions. JWST readings showed that the emitted photons came from molecules previously identified in Atlas's organic outgassing cycles, particularly certain aromatic hydrocarbons known to fluoresce under specific conditions. Yet the timing of the emissions had nothing to do with spontaneous fluorescence. The photons arrived in precise bursts, spaced so consistently that analysts initially suspected a calibration error. But when multiple observatories independently recorded the same sequence, the truth became undeniable. Atlas was producing light intentionally, or at least through a controlled internal mechanism. Spectral breakdown revealed that the luminous pulses had distinct profiles. The leading edge of each burst carried a sharp spike in the blue ultraviolet band, followed by a soft tail in near-infrared wavelengths, a pattern strongly reminiscent of biological bioluminescence decays seen in Earth organisms. However, the decay curves from Atlas were far too efficient, clean, consistent, and mathematically smooth, with none of the chemical noise typical of living systems. This paradox raised an unsettling possibility. The emissions resembled life, but with the precision of engineered photonic controls. As deeper analysis continued, researchers uncovered a phenomenon even more striking. The pulses changed amplitude depending on the phase of Atlas's rotation, aligning with the object's orientation relative to Earth, as if the luminous output formed a directional pattern. Sometimes the pulses strengthened when Atlas faced our observational angle, other times they dimmed or shifted frequency. These modulations remained faint enough to fall below the threshold of deliberate communication, yet too structured to dismiss as coincidence. Some teams proposed that the glow served as an internal diagnostic cycle, a kind of photonic stability check triggered by changes in environmental stress. Others speculated it might be a navigation cue, a luminous mechanism to orient the object through sparse interstellar regions where sunlight could no longer serve as a reliable guide. A more daring group suggested the emissions might represent an ancient signaling system, residual, automated, perhaps non-sentient, but designed to broadcast status or location. Whatever the purpose, the bioluminescent-like activity made one fact unavoidable. Atlas was generating and modulating light with intentional rhythm, spatial organization, and environmental sensitivity. No natural object had ever exhibited such behavior. The line between photonics, chemistry, and purposeful expression blurred, and Atlas's faint glow pulsing in the dark like a distant heartbeat became one of the most enigmatic signatures yet of its underlying complexity. The steadily growing catalogue of anomalies surrounding Atlas reached a tipping point when researchers began integrating all of the object's seemingly independent behaviors, thermal pulses, chemical rhythms, chiral flows, reflective oscillations, isotopic gradients, and photoluminescent emissions into a unified analytical model. What emerged from this synthesis was not a scatter of unrelated phenomena, but a coherent pattern of coordinated activity, as though each subsystem functioned within a larger harmonized framework. Data analysts noticed that Atlas's thermal pulses aligned not only with its molecular emissions, but also with shifts in reflectivity, phase change cycles, and even the timing of its photonic bursts. These events followed harmonic ratios, mathematical relationships too precise to arise from chance interactions among independent physical processes. Instead, the patterns behaved like coupled systems working in resonance. Using Fourier analysis and wavelet decomposition, researchers identified recurring frequencies that appeared across different modes of observation. A thermal pulse that repeated every 247 seconds had a counterpart in the amplitude oscillation of the bioluminescent glow. A reflectivity shift seen in the ultraviolet band occurred exactly halfway through the cycle of a nitrogen-phosphorus emission sequence. A subtle acceleration along Atlas's trajectory coincided with one of its heat redistribution waves. Each anomaly, previously perplexing on its own, became deeply unsettling when viewed together. The synchronization suggested not passive coincidence, but internal regulation. Atlas didn't just pulse, glow, emit molecules, and adjust orientation randomly. It performed these actions in lockstep, following what looked like an intrinsic logic governing the entire body. The object's non-gravitational accelerations, already difficult to explain through solar radiation pressure or outgassing, mapped onto these harmonic cycles with eerie precision. Small deviations from predicted trajectories occurred at specific points in the global timing sequence, as if Atlas used its chemical jets, thermal vents, or phase shift zones to make micro-adjustments that kept it aligned with an underlying operational schedule. The absence of visible propulsion made these accelerations all the more perplexing, leaving researchers to speculate about mechanisms ranging from distributed microventing to exotic forms of momentum transfer that did not rely on mass ejection. Meanwhile, machine learning models tasked with identifying patterns across the datasets discovered an emergent property. Atlas's varied behaviors formed feedback loops. When thermal load increased, chiral molecular flow intensified. When molecular emissions peaked, bioluminescent pulses strengthened. When pulses strengthened, minor reflectivity shifts followed. These loops didn't spiral into chaos but stabilized into repeating cycles, like closed circuits designed to maintain equilibrium. Some theorists suggested that Atlas could be executing autonomous regulation routines, perhaps a survival strategy preserved over billions of years, or a diagnostic protocol monitoring its own structural integrity. Others speculated that the harmonic synchronization indicated an ancient navigational or sensing system, interpreting and responding to its cosmic surroundings. A minority posited something more profound. that Atlas's entire behavior resembled a multi-layered communication architecture, with thermal, chemical, and photonic channels acting as interdependent signaling modes. However, no clear encoding or information content emerged, leaving the hypothesis enticing but unproven. Regardless of interpretation, one conclusion echoed across scientific institutions. Atlas operated as a single integrated entity, not as a mass of disconnected geological or chemical processes. Its harmonized cycles implied internal coordination, purposeful, consistent, and impossibly complex. The object behaved like a system that monitored its environment, maintained its stability, and adjusted its behavior through multiple interacting subsystems. Whether those subsystems represented biology, technology, or a fusion of both remained unknown. But the coherence of their interactions marked a decisive shift in understanding. Atlas no longer appeared merely anomalous. It appeared organized, so profoundly and intricately organized that humanity had no precedent for the kind of entity it might represent. As the observational campaign widened to include precise astrometric measurements, Atlas's flight path revealed a dimension of intelligence, or at least intention, that no one had anticipated, because the object's trajectory consistently resisted the predictions generated by gravitational modeling, behaving as though it were navigating rather than drifting. At first, the deviations were small, subtle enough to attribute to unmodeled outgassing or minor thermal recoil forces, but that explanation collapsed quickly when the timing and direction of each deviation aligned with Atlas's internal harmonic cycles. Rather than responding to heating events or rotational asymmetries, the object appeared to be executing microcorrections at regular intervals, adjusting its path in ways that no natural body could coordinate. Gravitational simulators used by ESA and NASA attempted to reconcile Atlas's motion with known forces, yet the residuals, the differences between predicted and observed positions, formed a repeating pattern. Each shift occurred within a narrow window of Atlas's internal activity, usually immediately following a synchronized thermal pulse or a molecular emission cycle. The magnitude of these adjustments was too small to be the work of thrust, but too consistent to be random. This prompted researchers to ask whether Atlas possessed some form of distributed propulsion system hidden within its complex chemistry and heat flow, one capable of redirecting momentum through mechanisms so subtle they were nearly invisible. As Atlas approached regions of denser solar wind, its trajectory demonstrated anticipatory changes similar to those seen in its thermal regulation. Before the wind pressures intensified, the object pivoted slightly, altering its orientation with a precision incompatible with stochastic processes. These reorientations were not defensive reactions. They were preemptive, as if Atlas modelled the solar environment ahead of time and chose the optimal orientation long before the external forces reached it. Even more striking was the behaviour observed during its perihelion exit. Predictive models projected that Atlas would drift inward along a shallow curve, but instead it nudged itself outward through a sequence of minute course corrections, maintaining a track that preserved a strict harmonic interval with its internal cycles. No comet had ever done anything remotely comparable. The possibility that Atlas was following a deliberate path, perhaps one established billions of years earlier, began circulating in private meetings among mission directors. When analysts compared Atlas's orientation data to its chemical and photonic activity, they discovered correlations impossible to explain through blind physics. Each time Atlas rotated into a new alignment, a cascade of subsystems activated, thermal nodes brightened, photoluminescent pulses intensified, and emission bands shifted. This triad of responses suggested a coordinated navigational routine. Whether Atlas used these subsystems to interpret external cues such as magnetic fields, radiation gradients, or gravitational differentials remained unknown, but the synchronicity implied awareness, not conscious awareness in the human sense, but functional awareness, the kind that belongs to automated systems or adaptive organisms capable of interpreting environmental data. The object's non-gravitational acceleration patterns only deepened this impression. Each anomaly followed a logical vector, nudging Atlas into smoother trajectories, avoiding unnecessary angular momentum buildup, and maintaining a remarkably stable long-range path. It was as though the object prioritized a specific corridor through the solar system, correcting for drift in a manner indistinguishable from active navigation. The most conservative scientists suggested that Atlas might be executing pre-programmed pathways encoded into its structure, much like a seed drifting on air currents but guided by shape and internal design rather than conscious thought. The more radical interpretation, quietly growing in popularity, was that Atlas behaved like an entity that understood where it was and where it was going. Regardless of which explanation held true, the conclusion was unavoidable. Atlas was not drifting by chance. Its trajectory was managed, guided by internal mechanisms that modulated its motion with a precision reminiscent of spacecraft or living systems with directional instincts. Atlas was navigating. As Atlas's catalogue of coordinated behaviours grew too vast to ignore, the scientific world found itself splintering into three competing interpretive camps, each proposing a radically different explanation for the object's nature, none of which could be dismissed. The first camp, the naturalists, argued that Atlas, however bizarre, must represent an extremely rare class of exotic natural object, perhaps one shaped by conditions never before observed. They proposed scenarios involving primordial molecular clouds, fractal mineral assemblies, quantum-stabilized lattices, or ultra-cold interstellar processes capable of encoding complex patterns without invoking life or design. These theories strained credibility, yet they offered the comfort of familiar physics. The naturalists insisted that the universe, vast and ancient, held room for extraordinary coincidences and edge cases. Their explanation was the least unsettling, but also the least satisfying in the face of mounting evidence. The second camp, the technologists, suggested that Atlas was not a natural object at all, but the derelict remnant of an ancient alien construct. They theorized that its internal subsystems, harmonic cycles and navigational adjustments, were vestiges of a once-functioning machine now operating in a degraded automated mode. According to this perspective, Atlas's chemical pulses and thermal pathways might be the fading heartbeat of an entity built eons ago, left to drift on a pre-programmed trajectory long after its creators vanished. The technologists pointed to the structured surface geometry, coordinated emissions and isotopic signatures as indicative of engineered materials. However, the greatest challenge to this interpretation lay in Atlas's age. If it truly originated billions of years before the Sun's formation, then any hypothetical builders would have developed technological capabilities unimaginable to humanity. The implications were staggering enough to make even proponents uneasy. The third camp, the vitalists, put forward the most controversial hypothesis, that Atlas might be a form of interstellar life, though not life as biology defines it. They proposed that Atlas could be a macroscale organism or a distributed biosystem combining mineral, chemical, and photonic processes into a coherent living structure. In this view, its thermal regulation resembled metabolic function, its molecular emissions were biochemical cycles, and its photoluminescent pulses served signaling or homeostatic roles. Vitalists argued that the harmonic coordination of Atlas's subsystems echoed the emergent synchronization found in complex biological entities. Some even speculated that Atlas could represent an evolutionary pathway entirely separate from carbon-based cellular life, a kind of geologic organism shaped by aeons of cosmic drift. Critics countered that an organism kilometers across, capable of surviving billions of years in interstellar space, stretched the concept of life beyond recognition. Yet vitalists responded that terrestrial biology had no monopoly on the definition of life. The debate escalated behind closed doors, sparking fierce arguments in conference calls, encrypted briefings, and classified meetings across scientific and government institutions. No group could decisively refute the others. Every explanation, natural anomaly, engineered relic, living entity matched part of the evidence while contradicting another. The triple interpretation collapse created a vacuum of certainty, a space in which the scientific method struggled against the unprecedented nature of the object under study. Meanwhile, Atlas continued to behave in ways that supported all three theories. Its geometric stability evoked engineering, its chemical rhythms resembled biology, its isotopic composition pointed to ancient cosmic processes. As each side gathered ammunition for its argument, the sobering truth settled in. Humanity had encountered something for which no existing framework was adequate. The three interpretations were not competing answers. They were partial truths circling an unknown category, something neither wholly natural nor wholly engineered, nor wholly alive, but occupying a frontier where all three concepts converged. The global response to Atlas entered a volatile new phase once governments realized that the object's behavior, its synchronized cycles, trajectory adjustments, and harmonic emissions could have strategic implications, prompting agencies to classify findings, restrict information flow, and initiate covert analyses that diverge sharply from the open scientific discourse of earlier weeks. Intelligence communities feared that Atlas's arrival might not be a passive astronomical event, but a potential precursor to something, whether technological, biological, or communicative, that required immediate assessment. As a result, data previously shared across international observatories began funneling into secure networks, and several national space agencies quietly withdrew public access to their high-resolution scans. Leaks soon revealed that at least 3 countries had begun modelling Atlas's internal cycles as potential signalling frameworks, searching for encoded patterns that might indicate intent. Analysts examined the timing of photonic pulses, thermal ripples, and chiral flows, hoping to detect non-random information sequences. While no explicit message emerged, the structured nature of the cycles led some agencies to hypothesize that Atlas might be broadcasting environmental status or conducting automated diagnostics functions that could inadvertently reveal operational principles valuable to foreign powers. This suspicion triggered a geopolitical arms race for understanding. Spacefaring nations equipped deep space listening arrays to monitor Atlas's emissions with unprecedented sensitivity. Some sought a scientific edge, others feared being left behind should the object prove to be a relic of advanced technology. Tensions grew further when orbital tracking stations noted that Atlas's micro-corrections produced minuscule gravitational ripples detectable in precision accelerometers, patterns subtle enough to seem intentional when mapped over time. The possibility, however remote, that the object's movements could influence navigation or orbital stability ignited debates within defense organizations about potential risks. Internal memos later revealed that at least one major power considered developing a mission to intercept Atlas, either to retrieve samples or to place a probe in close orbit for continuous monitoring. But engineers warned that the object's unpredictable orientation shifts and heat cycles made approach hazardous. A poorly timed maneuver could result in catastrophic failure if a spacecraft were caught in a thermal pulse or if Atlas altered trajectory unexpectedly. Meanwhile, within the scientific community, frustration mounted as the political clampdown limited collaboration. Researchers who had worked freely with international colleagues found themselves barred from sharing results, forced instead to brief government committees that lacked the expertise to interpret the data meaningfully. Some scientists accused their governments of sabotaging progress by treating Atlas as a national asset rather than a global phenomenon. Others, particularly those aware of leaked intelligence reports, feared that unrestricted communication might lead to misinterpretation or public panic. The world's media, sensing secrecy, amplified speculation. Rumours circulated that Atlas's harmonic cycles matched Earth-resonant frequencies, claims unsupported by actual data, but impossible to debunk without releasing classified information. Public anxiety escalated further when amateur astronomers noticed subtle changes in Atlas's luminosity, interpreting them as intentional signals. Conspiracy theories proliferated rapidly, ranging from predictions of impending contact to fears of unknown biological hazards. In response, several governments delivered carefully worded statements assuring the public that Atlas posed no immediate threat, yet these reassurances only deepened suspicion. Behind closed doors, the lack of consensus among experts haunted decision-makers. Was Atlas alive, automated, or simply an unprecedented natural structure? Was it approaching the inner system by chance or by design? And most importantly, what would it do next? The inability to answer these questions created a vacuum that governments filled with caution, secrecy, and increasingly fear. The world had encountered a phenomenon that defied every category it depended on to understand reality. And as Atlas drew closer to the inner solar system, the stakes of misunderstanding it grew sharper, pushing humanity toward a threshold it was profoundly unprepared to cross. As Atlas approached the final leg of its passage through the inner solar system, scientific uncertainty gave way to a tense anticipatory silence, for the object's next actions would either clarify its nature or plunge humanity deeper into confusion. It was during this phase when Atlas crossed a critical boundary of solar illumination, that its behavior shifted once more, revealing a new level of complexity that unsettled even those who had grown accustomed to its anomalies. Instruments detected a reconfiguration across its entire surface. The hexagonal, reflective motifs began rotating independently of the object's main body, each tile pivoting in fractional degree increments until the entire shell resembled a tessellated field of shifting mirrors. These rotations were not random. They aligned into wave fronts that propagated from pole to equator, causing Atlas to redirect sunlight in sweeping arcs that flared across space like controlled reflections. These flares were too structured to be incidental. They produced narrow beams that spanned millions of kilometers, intersecting precisely with regions of enhanced solar wind density. When the beams fired, Atlas's trajectory stabilized slightly as though the reflected light contributed to its course corrections. This newfound behavior introduced a possibility that few had dared consider. Atlas might be preparing for a transition. Simultaneously, internal thermal cycles intensified. Instead of the steady 247-second rhythm that had held for weeks, the pulses accelerated, compressing into intervals closer to 180 seconds, then 160, creating a rising harmonic series reminiscent of a system spinning up or recalibrating for a new operational mode. Photoluminescent emissions, once faint and heartbeat-like, expanded into sweeping auroral sheets that enveloped entire hemispheres, glowing in gradients of blue, violet, and near-infrared. These sheets pulsed in synchrony with the new thermal tempo, creating a multi-layered energetic resonance that no natural body could replicate. Then came the most startling shift. Atlas began shedding material in thin, filament-like arcs, ejected not explosively like cometary jets, but gently, evenly, as though the object were releasing accumulated compounds in a controlled discharge. These filaments exhibited properties unlike typical dust tails. They maintained cohesion over vast distances, forming spiraling structures that trailed Atlas in patterns resembling magnetic flux ropes. The composition of the filaments confounded expectations. They contained complex carbon frameworks interlaced with isotopically enriched oxygen and phosphorus, substances that had previously been locked within Atlas's structured interior. Their release seemed purposeful, almost ritualistic, like a shedding or seeding event. Some researchers proposed that Atlas was offloading excess material before entering a self-preserving phase. Others suggested it might be dispersing molecular information or preparing to transition into a dormant state once it exited the solar influence. A more radical interpretation emerged from teams studying the harmonic interactions among the new emissions. The frequency escalations, synchronized light patterns, gravitational micro-corrections, and controlled filament release all resembled the final sequence of a system completing a cycle, perhaps one that occurred only at long intervals measured not in years, but in millennia. As Atlas completed its inner system passage, its subsystems thermal, chemical, photonic, isotopic, reflective aligned into a rare moment of total synchrony. Sensors recorded a singular pulse, a massive unified emission spanning every detectable spectrum, from deep infrared to extreme ultraviolet. This event lasted less than a second, yet carried an unmistakable signature of coherence, like an entire organism exhaling or a machine executing a final command. After the pulse, Atlas quieted. Thermal cycles diminished to a faint hum. Photoluminescent patterns faded, and reflective tiles returned to their slower, earlier oscillations. The object adopted a serene, almost dormant posture as it drifted outward on a stable, predictable course. Humanity was left with no clear resolution, only the knowledge that Atlas had performed a highly orchestrated sequence at the exact moment of closest approach, a sequence that hinted at purpose without revealing purpose. Scientists were forced to confront a humbling truth. Whatever Atlas was, natural anomaly, ancient relic, interstellar organism, it operated on timescales, principles, and intentions beyond human comprehension. Its passage had opened a window into a category of existence previously unimagined, leaving behind data that would take generations to decode, and as Atlas receded toward the outer system, its long, spiraling filaments flowing behind it like a cosmic wake, the world understood that the encounter had not given answers, but an invitation, one humanity had only begun to fathom.